The following is an AZPM original production.
Arizona Science is supported by Research Corporation for Science Advancement.
For Arizona Public Media, I'm Tim Swindle, Professor Emeritus of Planetary Science at the University of Arizona, and this is Arizona Science. Joining me today is Dave Sand, a Professor of Astronomy at the University. Welcome, Dave.
Good to be here.
Dave, you've been studying some very faint galaxies that have been recently discovered. How do these compare to normal galaxies?
Oh, these galaxies are quite faint. So a normal galaxy like our Milky Way may have 20 billion stars or something like this. The smallest of the galaxies we found in the study has about 40 or 50,000 stars in it. So it's many orders of magnitude fainter. These types of galaxies are the smallest galaxies we know of, or the smallest objects we know of that have a dark matter halo associated with them.
What does a dark matter halo mean?
Well, it's a little bit hard to know because we don't know what dark matter is. But when we measure the motions of stars in these galaxies, in any galaxy really, there seems to be more mass there than we could account for if we just add up all the stars and gas and dust and other things. These are systems where the stars are moving around faster than you expect just from the stars and gas alone.
How do you discover such faint galaxies?
There are easy ways to view large fractions of the sky, just scan through them very quickly. I was doing this in particular regions of the sky because I knew these little faint dwarf galaxies should be there. So I just did it by eye, found 3 of them very easily. I had found one earlier as well. And they just pop right out when you look at these images.
Once you discovered them, how did you go about studying them?
There are digital sky surveys. Most of the sky is covered by them. They're actually quite deep at this point. Over the last 20 years, we've really gotten better at this. They weren't deep enough to really understand these objects. So we applied for time at Gemini Observatory. This is an 8-meter telescope. There are actually 2 8-meter telescopes, one in Hawaii, one in Chile. One of the telescopes we do have access to is Magellan down in Chile. That would have been great for this. It was just the timescales. Let's get it done really quick in a couple months. The Gemini telescopes are national facilities. All astronomers have access to them, and we took advantage of that. It's a really great resource.
What did you find out about these galaxies?
They were kind of little smudges with stars in them at first when I discovered them. And when you go deeper, you actually resolve some of the smudginess into individual stars. That lets us kind of study what types of stars they are. In this case, they were old. We call them metal poor stars. They're very chemically poor. Okay, it indicates that the stars in the system were quite old, or at least hadn't been chemically enriched through multiple generations.
What do you mean by old? How old do you mean?
Well, we think these stars are, let's say, between 10 and 12 giga-years old, which is 10 or 12 billion years old. The universe is about 13.5 billion years old, so we think this is a very old galaxy we're looking at. We saw no evidence of young stars at all. Another way you could kind of look for this is in ultraviolet light. And so we looked at, again, archival data, ultraviolet data. You need a satellite to look in the ultraviolet. And so there have been some NASA satellite missions, the Galaxy mission in particular. There was no emission at all. It was like a blank spot in the sky. And that really tells you that there are no young stars there at all.
You've used the term deep a couple of times. Could you explain what you mean by a deep survey?
Yeah, so it just means that, you could think of a telescope as a light bucket. So if you have a big bucket, you could collect more rain outside. If you have a big telescope, you could collect more light. The more light you could collect, the fainter little stars you could see. So if I just go outside with a small telescope, I may see the blob of a nearby galaxy. But if I go deep with a big telescope, I may actually turn that blob into individual stars. And that's what I mean, is see fainter and fainter stars associated with these galaxies.
Thanks for talking with us.
No problem. It was fun.
Our guest today has been Dave Sand, who studies the formation and evolution of galaxies. This is Tim Swindle, and you have been listening to Arizona Science. You can also listen to this and other Arizona Science segments by going to the AZPM website at azpm.org.
Thank you to Research Corporation for Science Advancement for their support of Arizona Science. AZPM's original productions are made possible in part by donations from listeners like you. Learn more at support.azpm.org. Thank you.